Anything that makes your tires last longer can improve your bottom line. Long-wearing tires are a big help, provided that you get every bit of usable wear out of them. To keep your removal mileage high, you need tires with slow and uniform wear. Wear is caused by abrasion. If we keep turning this pencil so that the abrasion is evenly distributed, we get uniform wear. But if we concentrate the abrasion in one place, the result is irregular wear. If one part of a tire is worn more than some other part, we say that tire shows irregular wear. And unfortunately, the part of the tire that wears out first determines your removal mileage. That's because when any part of a tire is completely worn, you have to remove the tire from service. If you don't, the tire may lose air prematurely, or the casing can be damaged so badly that it can no longer be retreaded. Why is irregular wear a problem on some tires but not on others? Pickup and delivery fleets are constantly stopping, starting, turning, backing, and maneuvering, and rarely have problems with irregular wear. This is probably because their tires wear so fast that irregular wear never really gets a chance to start. Their tires don't last very long, so removal mileage is generally lower than that of line haulers. But irregular wear is usually not a problem. On the other hand, for some coast-to-coast haulers, normal tire wear tends to be very slow. That's great, because their tires can last many, many miles. Unfortunately, it also means that irregular wear gets lots of chances to start and grow. High projected removal mileages can be cut short by excessive irregular wear. In general, even though anybody can experience irregular wear, fleets with high miles per 30 seconds see most of it. Even so, not every kind of irregular wear is a problem or cause for alarm. Especially with river or wavy wear, a tire may already have provided miles of useful service and may have many thousands more miles yet to go, regardless of how it looks. Good record keeping is the only thing that will tell you if you're getting your money's worth out of your tires. Cost per mile over a tire's total life cycle is the most important factor. Not all causes of river wear are well understood, but it tends to show up on tires with very high miles per 30 second. A similar phenomenon starting from the outside shoulder rib can leave behind raised islands in the tread. In extreme cases, these islands can cause vibration and ride disturbances. But if the tire is not creating a ride disturbance, and if you're not risking casing damage, there's no reason to remove it from service. It's also important to know that irregular wear cannot be cured, only reduced. Once it starts, it only gets worse, never better. A few forms can be equalized by changing the direction of tire rotation. And in some cases, a tire with irregular wear can be moved to another wheel position for the remainder of its useful life. The real solution is prevention. Many forms of irregular wear can be prevented. Early detection and understanding of possible causes and prompt action make all the difference. Detection is pretty easy. Drivers and mechanics should take responsibility for monitoring the appearance and feel of tires, fuel economy changes, and for reporting ride disturbances. Diagnosis is the hard part. Many kinds of irregular wear involve a combination of processes. Different processes can produce similar symptoms. Even if there's one primary cause, the combination may make diagnosis difficult. A checklist of potential sources of irregular wear might include conditions, equipment, maintenance, alignment, manufacturing, road hazards. The tire is the messenger, telling you that something is wrong somewhere. Your tire supplier will be happy to help you with irregular wear problems, and a book from the Maintenance Council of the American Trucking Associations may provide additional help. It's called the Radial Tire Conditions Analysis Guide and is a comprehensive review of tread wear and tire conditions. In the next few minutes, we'll look at some known causes of irregular wear and suggest some things you can do to reduce or even eliminate them. Basically, we know three things that can cause irregular wear: dragging or slipping as the tire rolls, bouncing or skipping, and the nature of the tire itself. Let's start with dragging or slipping. In some cases, while the tire is rolling, it may also be pulled to one side or the other, creating what are called side forces. Some side forces, as in turning, are unavoidable. Turning forces deflect the vehicle from a straight path, and the steer tires have to absorb these forces. The tighter the turn, the more force there is. With normal axles, a turn can be about 32 to 35 degrees. Setback axle tractors allow even tighter turns, up to 45 to 50 degrees, and put even more side force stress on tires. Load adds to these forces. Steer tires are often the most heavily loaded ones. This model truck and an ordinary postage scale can help us see the load. Each steer tire may be carrying some 6,000 pounds of load, whereas fully loaded drive and trailer axles rarely exceed 4,250 pounds per tire. The position of the fifth wheel can throw even more weight on the steer axles, and setback axles can have the same effect. The result is that side forces on steer tires can be enormous. Drive and trailer tires can also be subjected to side forces by being dragged sideways during tight turns. This can occur on any pair of non-steerable axles, but is strongest on spread axle trailers. Not only are the tires being dragged, they may actually stop and reverse direction, creating still other wear patterns. There even are turning side forces that aren't so obvious. If a truck is out of alignment, it may be trying to turn all the time, even though it might look like it's not. When we say that a truck is aligned, we mean that all of the tires and wheels and the vehicle are traveling in the same direction. Notice that we said all tires, not just the steers. Any tire that is out of alignment can develop an irregular wear problem, or worse, can cause an irregular wear problem to occur on another tire. And here's why. If a tire is turned, even slightly, but has to travel along a straight path, side forces between the road and the tire create abrasion, just the way this file distorts and abrades this piece of foam. Even if the turn is very slight, mile after mile of this kind of abrasion can lead to serious irregular wear. In fact, this directional abrasion is an important clue in diagnosing alignment problems. You can often detect this abrasion by running a bare hand across the surface of the tread. If the edges of the tread elements feel sharp or feathered one way and smooth the other, side forces have probably been at work. A close-up look at the tread element edges may reveal tiny ribs or wrinkles created by abrasive side forces. On steer axles, incorrect toe settings can cause this kind of problem. If steers are not correctly aligned, they can rub their way down the road rather than rolling the way they're supposed to. Toe-in problems usually show up as feathering on the inside edges of the tread elements and rounding on the outside edges of both tires. Toe-out tends to cause feathering on the outside edges and rounding on the inside ones. Incorrect Ackerman angle can also have a similar effect. When a truck turns, the tire on the inside turns more sharply than the one on the outside. If the Ackerman angle is not correct, side forces can cause one or the other, or both tires, to develop irregular wear. And yet another place where toe-in and toe-out problems can occur is on dollies. With a badly worn dolly, acceleration can create toe-out wear, while deceleration creates toe-in, so both conditions may show up at the same time. Tandem axles in both drive and trailer positions need to be fixed perpendicular to the geometric center line of the vehicle. If both axles are turned the same way, the thrust angle is said to be misadjusted. If each axle is turned a different way, we say that we have a scrub angle misadjustment. If the drive axles are the ones out of alignment, the truck is literally pushed out of straight line travel. If the trailer axles are out of alignment, the truck is dragged out of straight line travel. Either way, the tractor and trailer can end up traveling out of line, the so-called dog tracking effect. Looking in the mirrors, the driver may be able to see more of the trailer in one mirror than in the other, and it may also be possible to feel the problem in the wheel. Drive axle misalignment usually produces a more or less constant pull to one side, requiring a constant steering input to maintain straight travel. With trailer axle misalignment, on the other hand, the truck tends to wander. The driver must first turn the wheel one way, then the other to maintain straight travel. So, while misaligned drive axles tend to cause pull, misaligned trailer axles tend to cause wander, important clues to the location of the problem. And because the misaligned axles are slightly turned, there are side forces on the misaligned tires that can cause feathered and rounded wear. The feathering will be on the side to which the tire is turned, on both tires, instead of on opposite sides, as in the toe-in or toe-out situation. You can feel the result, or see it as rounding of the tread element edges. In addition, because the steer tires have to be turned to counteract the forces created by the misaligned axles, the steer tires are also subject to irregular wear problems. In fact, it turns out that any drive or trailer axle with a thrust or scrub misalignment can cause irregular wear to appear on almost any other axle. For example, misaligned drive axles can cause irregular wear on drive and steer tires, while misaligned trailer axles may result in irregular wear on trailer, drive, and steer tires. Alignment experts say that in their experience, drive axle misalignment is the single most troublesome alignment problem. Misaligned trailer axles are the second biggest troublemakers, and it may come as a surprise, but steer axles actually produce the fewest alignment-related tire problems. Fifth wheels should always be well lubricated because rust or corrosion can cause them to bind, resulting in undesirable side forces being applied to the tires. And pintle hooks should be inspected regularly for unusual wear. The only way to avoid many of these problems is to check and align your vehicles on a regular basis. Performing a total vehicle alignment is a lot of work and requires precision equipment in the hands of trained personnel. The reason is that a tiny misalignment is magnified by the many miles a truck travels between alignment jobs. With this laser alignment equipment, we're checking drive axle thrust against the steer axle. With just 2 inches of misalignment over a 181-inch wheelbase, the steer tires have to pull the vehicle a full 58 feet to one side every single mile to keep the truck running straight. In the course of 100,000 miles, those tires are scrubbed some 1,100 miles sideways. That's a lot of unnecessary wear, most of which will probably show up as irregular wear on both the steer and drive tires, leading to premature removal. So, misalignment can make a big difference in irregular wear, while constantly fighting the wheel increases driver fatigue. And since all of these various side forces have to be overcome by power from the engine, misalignment can even hurt fuel economy. The result? Routine, precision alignment can pay on the road, in the cab, and at the pump. Regardless of wheel position, tires, wheels, and worn parts can also cause side force irregular wear. If a tire is mismounted or mounted on a bent wheel, lateral runout can cause the tire to wobble, scrubbing the tread against the pavement. Another way this may happen is if the tire is not properly balanced. This model is meant to represent a single tire and the forces that act on it as it turns. With the tire in a properly balanced condition, it spins smoothly without bouncing or wobbling. If we place the weight so that the tire is not dynamically balanced, we see that it wobbles from side to side. The forces this wobble creates have a similar scrubbing effect to the ones created by lateral runout. In cases like this, one clue may be that the tires on just one end of an axle show irregular wear. There even are side forces that come from the environment rather than the equipment. Road crown is one example. According to information from a variety of highway departments, in the south, roads are crowned fairly steeply to make water run off. While in the north, road crowns tend to be flatter to keep slow-moving vehicles from sliding off icy roads. There's nothing you can do about road crown except to be aware that it is a factor. The same thing is true of crosswinds. A strong, constant crosswind will cause a corresponding steering angle input correction that will contribute to irregular wear. These forces may vary with travel direction, season, even time of day. Again, there's nothing you can do about crosswinds, but they may help explain some types of irregular wear. So far, we've talked about forces that drag tires sideways, but tires can also slip or scuff in the same direction as they normally travel. When this happens, the tire may be skidding and rolling at the same time. This phenomenon can occur on duals if there are tiny differences in tire diameters caused by mismatched tire sizes, mismatched tread depths, or mismatched inflation pressures. If one tire is smaller than the other, it cannot cover the same distance in a single revolution as the bigger tire. But because the tires are bolted together, it has to cover the same distance. What happens is that the bigger tire scuffs the smaller tire over that extra distance every time it goes around. The smaller tire can run hotter and wear faster. It may even act as a brake, holding the vehicle back, wasting fuel. In this example, we measured this tire's circumference by rolling it across the shop floor. Then we dropped inflation pressure 5 psi and measured the circumference again. With just 5 psi difference, we found a circumference difference of 5/16 of an inch. That doesn't sound like much until you figure out how much that is over a year's usage. This mismatch could result in dragging the smaller tire over 13 feet every mile. In 100,000 miles, this works out to more than 246 extra miles of pure scuffing wear on the smaller tire, like spinning the tire on the pavement for the equivalent of 246 miles. And that's with the difference of just 5 psi. That's tough to see with a tire square because it only represents a difference of a few 30 seconds in diameter. 5 psi may not sound like much, but how many dual assemblies match pressure that well day in and day out? The Rubber Manufacturers Association recommends that radials in dual assemblies be matched within 3/4 inch in circumference or within a 1/4 inch in diameter. But this dragging effect doesn't just occur on duals. Similar problems can occur with single tires. We've been looking at 2 tires bolted together, but if you think of a 5-rib tire as 5 separate tires bolted together, you can see how this can happen. If a manufacturing variation makes one or more of the ribs lower than the others, we have the same situation as with a mismatched dual assembly. The lower ribs will be dragged by the larger ones. This could cause rib punch wear, where some ribs are worn much more than others. Other possible causes include incorrect inflation pressure or incorrect rim size. This test equipment allows us to visualize footprint pressure. The tire is pressed against a device which creates a map of pressures within the footprint. The distribution of colors that you see represents the distribution of pressures within the footprint. As we can see, pressures vary within the footprint. In a perfect world, the colors would be all the same. With the correct inflation pressure for the load, we have a near-ideal footprint, with excellent pressure distribution and slightly rounded corners. With too little inflation for the load, the footprint elongates, the corners become squarish, and wet traction may be reduced. On the other hand, with too high an inflation pressure for the load, the footprint becomes shorter and rounder. Pressure is more concentrated in the center, and dry traction may be reduced. Similar things can happen with the incorrect rim width. A rim that's too narrow produces an effect somewhat similar to overinflation. Too wide a rim produces an effect somewhat similar to underinflation. So, incorrect inflation pressure for the load, or incorrect rim width, can have much the same effect as mismatching of tire or rib sizes. Dragging or scuffing effects can occur that lead to irregular wear. And just as inflation and rim width can affect the distribution and shape of footprint pressures, so can camber, which is the inward or outward tilt of the wheel. Similar effects result with the side of the tire, with the lower footprint pressure being dragged by the side with the higher footprint pressure. Up to now, we've looked at situations where side or inline forces produce more or less constant dragging on the tread surface. Whereas constant drag tends to affect an entire rib or even the entire tread surface, abrasion can also be intermittent, which can produce highly localized wear patterns, which may even be confined to spots on the tread surface. With brake lock, the tire may actually be out of round, while with some other conditions, it may behave as though it were. The result is bouncing or skipping forces. For example, a tire which is mismounted so that it has excessive radial runout will cause bounce. And as we see on our tire balance model, a tire that is not statically balanced will cause bounce, even if the wheel and mounting are correct. Flat spots, like those that result from brake lock, can also cause bouncing or skipping. Even if everything about the tire and wheel is right, worn shocks or misadjusted airbags can cause a similar problem. Unlike the other forces we've seen, bouncing is concentrated at certain points on the tire circumference. As you'd expect, so is the irregular wear that results. The irregular wear may appear in just one spot. Over time, it may grow to form a large diagonal patch that runs from shoulder to shoulder. This can disturb the balance of the tire enough to cause even more bouncing, ride disturbance, and suspension and bearing wear, all of which can make irregular wear worse or even create new irregular wear locations. In extreme cases, diagonal wear can appear at regular intervals all the way around the tire circumference. It's a vicious cycle that can quickly destroy a tire. If brake lock or diagonal wear has caused flat spots on a dual assembly, you may be able to clock the flat spots 180 degrees apart to minimize the ride disturbance. Such tires need to be carefully watched to prevent wear from damaging the casing. Just as brake lock can be a seed that causes irregular wear to grow, other tread surface damages can have a similar effect. A stone retained in a groove can distort the neighboring ribs, causing localized abrasion that can grow into irregular wear. When the stone is eventually removed or released, the worn spot can continue to grow, spreading irregular wear across the tire surface. This is a good reason to periodically inspect for stone retention and remove any trapped stones. If stone retention is a problem for you, you can choose tires designed to reject stones. Chipping, tread chunking, or tearing resulting from incorrect tire selection or improper operation can provide similar starting points for irregular wear. Finally, the nature of the tire itself may lead to certain types of irregular wear. Drive tires with block treads can wear in what is called a heel and toe pattern. What is happening is that as the block comes in contact with the road, it's compressed. All of that stored compression energy is suddenly released with a snap as the block loses contact with the road. The blocks can wear at a sloping angle, as we see here. Heel and toe wear can progress to the next row of blocks and eventually can develop into full diagonal wear. It can be aggravated by the kind of overinflation that can occur when trucks go out loaded but return empty. If you catch it early enough, irregular wear can sometimes be equalized by switching tires to opposite sides of the vehicle. This changes their direction of rotation, which causes the blocks to wear in the opposite way and can greatly increase drive tire removal mileage. As we've said, different tires can have different irregular wear characteristics. Tire manufacturers provide many different designs, allowing you to select the tires that last longest for you. The defense groove feature, common on rib radials intended for long-distance hauling, acts almost like a barrier, reducing the likelihood of the spread of shoulder edge wear to the tread surface. Nevertheless, haulers who do lots of pickup and delivery work may find that this feature is not suitable for them because of potential rib tearing or stone retention. Along the same lines are tires with what are called see-through or continuous straight grooves. Straight grooves help tires roll in a straight line with less steering input and rolling resistance, and are especially suited to users who make long hauls at highway speeds. On the other hand, zigzag grooves provide lots of biting edges for traction on wet city streets and help reduce side force effects. This makes them ideal if you do lots of turning and maneuvering. Unidirectional tread patterns, where the tire is designed to rotate just one way, can be optimized to minimize irregular wear, especially for long-distance hauling. On drive tires, wide shoulder ribs can provide resistance to side forces, permitting the use of very deep tread depth for extremely long tread life in long-distance hauling situations. On shorter hauls, shallower drive tire tread depth can help resist the squirm that constant turning creates. If your work takes you even occasionally onto gravel or badly worn asphalt, tires with platforms or specially designed groove side angles can reduce stone retention that can lead to casing damage and irregular wear initiations. And tiny notches or sipes along the edges of grooves can help relieve rolling stresses that can cause river wear to start and spread. All of these things reflect the efforts of tire manufacturers to design tires that last longer by resisting irregular wear. With these new quality designs, quality manufacturing is essential. Whereas old systems of quality control tried to keep tires with manufacturing variations from being shipped, the newer concept of total quality management tries to keep tires with manufacturing variations from being made. This provides the dual benefit of higher quality and lower cost. And what can you do to reduce irregular wear? We suggest that you be smart. Select the right tire for the job. As we've seen, different tires are designed for different uses, different vocations, different axle positions. Consult your tire supplier for help in selecting the best tire for you. Maintain your tires and vehicles. Worn parts and improperly mounted and balanced tires can all cause irregular wear. A regular vehicle maintenance program, together with constant attention to proper inflation, will pay off in higher removal mileages and lower operating costs. Align your vehicles on a regular basis. Have your tractors and your trailers aligned on a regular schedule. Do a total vehicle alignment, not just the steers. Begin by inspecting the vehicle for worn tires, worn parts, or any other conditions which might affect the alignment. Replace, adjust, or repair as necessary. And be sure to set all tire inflation pressures to the correct levels. Always get a set of before alignment readings before you adjust anything. Your alignment technician will be happy to explain the significance of each of your current settings. Just as important, don't change any alignment settings until you have a strong reason to believe that the change will improve your situation. Make sure that when your adjustments are complete, your settings fall into the middle of the range, not on the edge. This gives you a little margin should normal wear cause a shift. And set up a regular schedule for vehicle alignment. Use your experience to tell you how often you need it, but ideally, you should be doing alignments before problems occur, not as a response to them. Rotate tires, if necessary, to equalize wear. With some types of irregular wear, rotating tires can help equalize wear by canceling existing irregular wear patterns. Track performance of every tire throughout its useful life. Good record keeping is vital. Without it, you have no way of measuring your real cost per mile. Once again, your tire supplier will be happy to help you set up a record-keeping program. Obviously, reducing irregular wear can lead to higher removal mileages and therefore lower tire costs. At the same time, reducing or even preventing irregular wear can help improve retreadability by reducing casing losses. Whether you retread or not, this can help you save on your overall tire life cycle costs. And irregular wear is often associated with conditions that waste fuel or shorten the life of expensive bearings and suspension parts. Finally, reducing irregular wear and the conditions that cause it can lead to reduced ride disturbance, reduced driver fatigue, and fewer driver complaints. To get these benefits, be smart. Select the right tire for the job, maintain your tires and vehicles, align your vehicles on a regular basis, rotate tires if necessary to equalize wear. Track performance of every tire throughout its useful life. If you have questions or need assistance in making your fleet smart, call us. We'll be happy to help.